here. So we have integral of root of x times x plus 2. As I'm going to replace here is the x root of x by x to the power half. Now I'm going to open the bracket here, expand it, and we have x to the power half times x is going to be x to the power 3 by 2 plus 2 times x to the power half. So we have two power functions, and we just use a power rule. It's going to be x to the power, so the new exponent here going to be 3 by 2 plus 1. Okay, so that's why we'll get here 5 over 2, and we divide by 5 over 2. But dividing by 5 over 2 is same as multiplying with the inverse, going to be 2 over 5. Same for this one, and we get the solution. Any question? Is there any question regarding this example?
No, sir.
So I'll let you write down the solution first, and you guys can let me know when you're done. All right, so next. So we'll see again the substitution rule. So we did it last week in a case of definite integral. So we're going to repeat it again here in the case of indefinite integral. So you guys can see it's similar to what we did before, except here now we don't have the AB, the interval AB, and the new interval G of A and G of B, because we have indefinite integral. That's it. Okay. So again, you set u equal to g of x, and as I told you last time, your g of x is going to be always your inner function. And then you calculate your du, which is equal to this part, g dash dx is your du based on what you said at the beginning, u equal to g of x. And after using this substitution, you get a new integral, which is easier than the initial one, and you solve it. Now, when you solve it, for sure, your solution is going to be in terms of u, because your new integral now is in terms of u. And when you get the solution in terms of u, don't forget to substitute back, because your initial integral was in terms of x. Your solution should be in terms of x. So that's why when you guys use the substitution and get the solution in terms of u, don't forget the last step, which is, substituting back, u by g of x in order to get the solution in terms of x. Okay, so here are, three examples. So the first example, we have square root of 1 plus 1 minus 2x. And as I told you, you guys can see here, it's easier to find here, which is what is the u, the inner function. What you guys have here under the square root, this is going to be your g of x. So you set u equal to g of x. And when you guys use the substitution rule, you have to show all your steps. Okay, you show what you mean by u and what is your du. You have to write it, otherwise you will not get full mark. So you have u equal to g of x. In this case, g of x equal to 1 minus 2x. And the formula says you need to calculate du. But du is equal to, I'm just going to remind you the formula that we've seen last week. It's g dash times dx. We proved it last time. And we substitute gonna be g dash is the derivative of g. So g equal to 1 minus 2x. When you calculate the derivative of 1 gonna be 0 minus the derivative of 2x gonna be negative 2 dx. And now you're ready to substitute. So now the integral becomes, so here you guys can see you don't need to find new interval of integration like what we did last time, because last week it was about, you know, definite integral. That's why you have to find a new interval of integration. So here there is no interval because you have indefinite integral. We have to find a family of functions. Okay, so you will get just integral of, and you get root of u, because this is your u, and you substitute dx. You guys can see here your dx is gonna be du over negative 2. This is your dx. Now you substitute dx is gonna be du over negative 2. And your integral going to be, I can take, you know, never do negative 2 out of the integral because it's a constant going to be minus 1 over 2 integral of, but root of u guys can use it. You can write it as u to the power half and du. Now the integral going to be negative 1 over 2. Now use what the power rule says. The power rule says is going to be u to the power 1 over 2 plus 1. That's what the power rule says. And you divide by 1 over 2 plus 1 plus now the constant c. So this is equal to negative 1 over 2. So we'll get u to the power 3 over 2 over 3 over 2. Okay, I'm just gonna remove it because I didn't write it correctly. So we'll get here 3 over 2 plus c. And this is equal to negative 1 over 2 times 2 over 3. Because when you divide by 2 over 3, 3 over 2, sorry, it's same as multiplying with the inverse of 3 over 2, which is equal to 2 over 3. U to the power 3 over 2 plus now the constant c. Okay, now you simplify by 2 and you guys will get negative 1 over 3 now. And as I told you, the last step you have to substitute back because u at the beginning is right here. This is what you call u. Since your initial function or your initial integral was in terms of x, your solution should be in terms of x and not in terms of u. That's why you have to substitute back. So in this case, it's going to be 1 minus 2x to the power 3 over 2 plus now the constant c. And that. Any question? Is there any question? So don't forget the last step, to substitute back in order to get your solution in terms of the initial variable, which is x in this case. Can I erase this?
Yes, sir.
Thank you. So don't forget these two formulas when you set your u, how to get your du. And as I told you, your u going to be always the inner function. You calculate your du by calculating the derivative of g times dx. Don't forget this part, because you want to substitute here dx by its value. And you get the integral in terms of u only. And there is no x anymore. And then when you calculate now and get your solution in terms of u, don't forget the last step. Okay? All right, so let's see now the second example. So we have integral of sine x to the power 4 cosine x. So in this case, what's gonna be your u? You guys can tell me what gonna be your u in this case?
Sine raised to 4x into cos x.
Pardon?
Sine raised to 4x into cos x.
The whole thing is not in a function in this case. You take the entire function, because in this case, you'll not be able to solve it. If you said, for example, oh, I'm gonna miss the u. Just keep in mind, this is equal to integral of, we always use this notation, sine x, the whole thing to the power 4, at the meaning, times cosine of x. And you guys can see here, what is the inner function? Sine x, exactly. Okay. So you said u, thank you. So you are going to be, as your friend said, sine of x. And you calculate your du. So du gonna be the derivative of sine, and we know derivative of sine is equal to cosine x times dx. Don't forget times dx. And you guys can see, in fact, this is your u, what you have inside the bracket, and all this gonna be your du. So now you guys will get integral of u to the power 4 du, and you guys can see the integral becomes easier, right? You substitute the bracket by u, and the remaining part here is in fact equal to your du. In this case, you don't have to isolate your dx as we did in the first example. And now we're ready to use the power rule. So this is equal to 1/5 u to the power 5 plus the constant c. And last step, as I told you, you substitute back. It's gonna be 1/5. And we know u is equal to sine x. But when we drop the bracket, we know the notation of this sine x to the power of 5. The notation that we use is going to be just, when we drop the bracket, we have to move, the power 5. Is going to be sine x plus the constant c. And you're done. Yeah. Pardon? Where is it? du is right here. Pardon? Oh, you didn't attend the last class. No, because when the meaning of this is, the meaning is I'm calculating the integral with respect to u. That the meaning, and you find the antiderivative of u to the power 5. This is a notation. Okay, it's like when I ask you, for example, to calculate the derivative. Can you give me this? What is it? 5x to the power 4. And where is the dx? I didn't see here's the dx here. Where is the dx and this d at the top, on the top? Okay, because this is the notation here. What you have, this notation means derivative with respect to x. The denominator dx means with respect to x. Because anytime you differentiate a function, you have to say you're differentiating with respect to which variable. Okay? Because sometimes you can get a function depending on 2 or more than 2 variables. You have to mention you calculate the derivative with respect to x or respect to something else. It's the same for the integral. When you calculate the dx here, you see dx, you cannot say where is the dx. If I ask you to integrate, you did it in 1500 x to the power 4 dx. What is this? Based on what you did, I told you last week, this means find the antiderivative. And we've seen this is equal to x to the power 4 plus 1 over 4 plus 1. Plus now the constant c. Because this notation means find the antiderivative of x to the power 4 when x is a variable. That's the meaning of the dx. When you integrate, you already calculate the antiderivative. There is no dx anymore. It's like when you calculate the derivative here, there is no dx here anymore because you differentiate. It's a notation, and its meaning is integrate with respect to du, because u is a new variable of integration. That's what we use here to simplify our integral, because this integral at the beginning looks complicated. We simplify it, and when we get the solution, we substitute u by its value, which is sine of x. Okay? You're welcome. So be careful, the dx is not a function that you have to integrate. The dx means you're calculating the integral with respect to x. If your function is in terms of u, you will get du. If your function is in terms of y, you will get dy. For example, I can get integral of 1 over y dy. We did many examples last week. If I have 1 over y dy, we did one many example. The antiderivative is what we did last week, ln of absolute value of y, right? And plus the constant c. And last week you didn't ask me why, where is the dy? Okay, because here I calculate the integral with respect to y, means y is a variable. Here it's du. If, for example, it was like that, u, for example, to the power 4 dx instead of du, this means my integral is calculating with respect to x, and u does not depend on x. So it means u is a constant. This is going to be u to the power 4 x, because in this case, since my integral is dx, it means u is a constant. It's like 3, for example. Okay, and you guys can see here, this solution is different to what we got here, because here it was du and here it's a dx. Two different things. The d means you differentiating or you integrating with respect to x. If you du, it means you're integrating with respect to u. And if you integrate with respect to x and you have here u, it means u does not depend on x. You can just take it as a constant.
Sir, the cos x cancels off with the integrated like the cos x that's already there, yeah?
The cos is here because the whole thing is your du.
Du, so when it becomes du by dx, it eventually cancels off with the original cos x, right?
Yeah, because you don't need to do so, because it's the whole thing you can just replace directly.
Right, okay, yeah.
Yeah, so that's what I said, instead of using what we did in the first example, you don't, in this case, isolate your dx and replace it. If you do it, you will get the same thing. You substitute your dx is going to be du over dx over cosine, and the cosine cancel out.
Yeah.
But I just substitute directly, and in that case, I don't need to simplify. Is it okay? So in this case, I substitute all these, my du, as you can see here. If you want, it's going to be also, you can isolate your dx and then substitute dx only, the cosine cancel out, and you will get the same thing. Any question? And don't forget the last step here, as I mentioned, to express your solution in terms of x now, because your initial integral was in terms of x. U is just is introduced in order to simplify your integral. Is it okay for you guys? All right. I'm going to remove this and we'll see the third example. All right, for the third example, you guys can tell me what you can use as your u in order to simplify. Pardon?
The square root.
Exactly. Thank you. You can set u, your inner function is t u squared plus 5. and you calculate du. So from here, du gonna be, you have to calculate the derivative of this. The derivative gonna be 2t,
2t.
exactly, times dt. And now you're ready to substitute. So the integral now becomes equal to the integral of t cubed, and you have root of u. So from here, you guys can isolate your dt. dt is equal to du over 2t, because your new integral should be in terms of u only. You cannot get u and t inside the same integral. It should be in terms of u only. Okay, so I'll get here, when I substitute now dt by its value, you guys can see dt, I'm going to substitute. I'll get du over 2t. Now I'm ready to take it 2. I'll get here 2 out. I'll get 1 over 2 integral of. But you guys can see here I have t cubed and t. I can simplify by t. It becomes a t squared root of u. Is it okay for you guys?
Yeah, makes sense.
Thank you. Now, as I told you, this integral should be in terms of u only, and we still have t squared. And to get t squared, you guys come back here and find t squared. So we'll get here 1 over 2 integral of, but t squared, you guys can get it from here. I'm just going to change the color. You can see it. So from this step, you guys can see what is t squared. T squared is equal to u minus 5, right? I'm going to replace, because I have to express my new integral in terms of u only. That's the purpose of introducing u, in order to simplify my integral. So doing so, I'll get here u minus 5. But root u, I'm going to write it as u to the power half. Is it okay up to here? Any question? So from the, pardon? All right. I'm gonna now open the bracket. So to expand, the integrand, I'll get here 1 over 2. And I'll get here. So u times u to the power half is gonna be u to the power, what do you guys think? U times u to the power half.
U 3 over.
Pardon?
3 over 2.
3 over 2. You add the two exponents. So here's the exponent is 1 here, and plus 1 by 2 going to be 3 over 2 minus 5 times u to the power half. And again, we have the two power functions. So we're going to use the power rule. And we'll get 1 over 2. So if you guys calculate this one, going to be u to the power. Power rule says you have to add 1 to 3 by 2. You add 1, going to be 5 by 2. over 5 by 2. That's what the power rule says. The new exponent is equal to the previous one plus 1. So 3 by 2 is the previous one. You add 1, going to be 5 over 2, and you divide by the same thing. So minus 5, and again, it's going to be u. The new exponent going to be 1 by 2 plus 1 going to be 3 by 2 over 3 by 2. And now, plus the constant c. Is okay? Any question? So from here, I'm going to continue to the top here. Now I'll get 1 over 2 times. So you guys know when you divide by 5 over 3, it's same as multiply with the inverse. It's going to be 2 over 5. So u to the power 5 over 2 minus 5 times 2 over 3 u to the power 3 by 2 plus the constant c. Now if I drop the brackets, the 2 cancel out. So you guys will get now, so when you put it inside the 1 over 2, so we'll get 1 over 5 here, and u to the power 5 over 2. And you put this one, the 2 cancel, will get minus 5 over 3 u to the power 3 over 2 plus now the constant c. Is it okay up to here? Pardon? No, 5, because I put this 1 over 2 inside the bracket. This 1 over 2 at the front of the bracket, the first green line. You see, at the front, you have 1 over 2. When you put it inside the bracket, so you will get here 10 over 2. It becomes 5 over 3. So these 2 here, just gonna take the pointer. So you see, these 2, when you put it inside, when these 2, they cancel out. It becomes 5 over 3. You getting me? Okay. So now one more step. We have to substitute back in order to express our solution in terms of t, because the initial integral is in terms of t. So that's why I have to express my solution in terms of t. Don't leave the solution in terms of u. Otherwise, you guys will not get full mark. We just use u as a tool to simplify our calculation. Then we're done with u. We substitute back. So now the solution is going to be 1 over 5. Now you substitute u by its value. You guys can see u is here. It's a t squared plus 5. At the beginning, we set u equal to t squared plus 5. So we'll get now, bracket here, t we square it plus 5 to the power 5 over 2 minus 5 over 3. We substitute u by its value again. Is equal to t u square it plus 5 to the power 3 over 2 plus now the constant c. And we're done. So back substitution here, last step. Don't forget it. Any question? Is there any question?
No, sir.
Can I erase it?
Yes, sir.
Okay, so this example, conclude the 4th chapter. Next, I'm gonna introduce, the 5th one before letting you go. Can I erase it, guys?
Yes, sir.
All right.
Yes.
So we're done now with the definite and indefinite integral. All right. All right, so next we'll see the next chapter. As I said, chapter 5 is dealing with the applications of the definite integral. So we have many applications, in fact, but here we'll be interested in 2 applications, calculating areas and also calculating volumes. Okay, so today I'm gonna show you how to find areas, and then next tomorrow we'll see the volumes. And if you guys remember in the previous chapter number 4, so we've seen how to find the area of a region bounded by one curve, the x-axis, when x is between a and b. So today, so we'll generalize that concept. Instead of a region bounded by the x-axis and one curve, we'll be interested here in the area of the region bounded by 2 curves or more than 2 curves. It could be 2, 3, 4, 5, it depends on, the problem. Okay, so we'll see in this case how to generalize, what we did in a case of just one curve. So we'll cover, the following sections of the textbook. 6.1, that's exactly what we will cover today. And tomorrow we'll cover 6.2. Okay, and the rest we'll cover, next week. So here we'll see 2 methods in 6.2. we'll see two techniques, to calculate the volumes, and the third one will be cover, next week, the cylindrical shell method. So we have the disk method, the washer method, and the cylindrical shell method. So 3 methods to calculate the volumes. And to conclude this chapter, we'll see two case of areas. We'll be interested here in the area bounded by the x-axis and a pyramid curve. So we already seen how to sketch pyramid curve. So we'll be interested in the area of the region bounded by one pyramid curve and the x-axis, or the area of the region bounded by one curve or two or more than two curves, polar curves. Okay. So as you can see, it's going to be all about, applications of the definite integral to calculate areas. And sometimes the area could be very complicated. So we have to split it in different parts and calculate each of them. And also going to be the same for the volumes. Sometimes the volume is very complicated. So we have to split it into several volumes in order to get the total volume. Okay. So now, as I said, we'll cover, 6.1 today. And we are interested in these kind of areas. You guys can see, I want to get the area of this green region. And the region is bounded by the blue curve, which is the curve of F, and the red curve, which is the curve of G. And at the beginning, we assume here G of X is less than F of X. That's why the curve of G is below the curve of F because of this condition. And it's very important to get this condition in order to be able to calculate the area between the two curves. And to calculate the area as we did last week, we have to calculate, integral. But in this case, inside the integral, you guys will get the difference between the two functions because you want to get the area between the two functions. That's why you have to take the function f minus the function g in order to get this area, and you integrate it. Okay? Provided that now the function f is a greater function. So basically, it means when you want to calculate the area between two curves, it's going to be the integral in the appropriate interval, the integral of the greater function minus the smallest one. So here the greater function based on our graph is f minus g, and you integrate it from a to b. Doesn't matter, the region is above the x-axis or below. It's going to be always the greater function minus the smallest one, and you will get a positive number because you calculate, greater value minus the smallest one. You're supposed to get a number which is greater than 0. And here is, in this case, the formula. The area, as I told you, under this condition here, g of x is less than f of x. Otherwise, you don't have exactly this. It's going to be the greater function minus the smallest one. It's going to be the greater function minus the smallest one. And it's based on what he mentioned here. That's why the curve of G is below the curve of F. So anytime you guys want to apply this formula, make sure you already identify F and G. I mean, the greater function and the smallest one. And don't forget it. Oops, what I did here. Okay. And the question mentioned when x is between a and b, that's why you have to integrate from a to b. Now, anytime you guys want to calculate such area, you need to know if the question provides the values of a and b, and also you have to find which of the two functions, which one is the greater one, in order to apply the formula. Sometimes the question will not provide, the interval a, b, and you guys have to find it. We'll see next how to do it. Is there any question? All right, so since you guys don't have any question, we're gonna see the first example. All right, so now we wanna get the area of this region R, and the region is bounded by these two curves. It's a close one. And you guys can notice here, we don't know what is f in this case. By f, I mean, the greater function, because I want to apply this formula. As I told you, you need to know what is f between these two functions, which one is f. So which one is g? And before knowing that, I need to know the values of a is equal to what? I don't know. And also I don't know the value of b. Okay. So first thing that you guys have to do is to find the values of a and b after you will try to fix this problem. Finding, the greater function. This is f, and which one of these two functions is g. Okay. Now I have to find the values of a and b. Since my functions are in terms of x, you guys can see here, the function y depends on x. Here again, y depends on x. So that's why, the function is in terms of x. So it means I have to integrate with respect to x to use my dx here. And that's why I have to find the intersection point between these two functions. And in fact, what I need is not the intersection point. I need the x coordinate only, the x coordinate of the intersection point, because my functions are in terms of x. I don't need the y coordinates. I don't need them in my calculations. Since my functions are in terms of x, that's why. So next we'll see how to do it. All right. So here it is. As I told you, we only need the x coordinates of the intersection point, because the x coordinate gonna be my interval of integration in order to find a and b. And to find the x coordinates of the intersection point, you equate the two equations. This is the first equation, okay, equal to the second one. And that's exactly what we have here. So you have to equate the two equations in order to find. That's what I did here. And I move the negative x from right to left. It becomes plus x. We'll get 2x plus x. That's why we got here 3x. And I'm going to take x out. Don't simplify the x. If you do it, you will miss one solution. And I take here, factor out the x. And this product is equal to 0 if x equal to 0, or the second bracket equal to 0. And second bracket equal to 0 means x equal to -3. So in this case, I have the values of a and b. And a gonna be always the smallest value. So in this case, it's gonna be -3, and b is 0. So it means you have to integrate from -3 to 0. Okay. Now I got I got the value of a and b. So when I apply the formula, I'll get here integral from -3 to 0, because my a here, this is 0 in this case, and this one is the smallest value. Always don't forget it. You integrate from the smallest value to the largest one. Don't integrate from 0 to -3. Now, next step, as I told you, you find a, and now we fix it. A is equal to -3 and b equal to 0. Next step, we have to find f and g in order to apply. So we have two possibilities. So if the graph is given, it's going to be easier, because the graph going to show us, the function which is on the top, and the graph, the function on the top going to be the greater function. Okay, so since you don't know the graph, now the other way to find the greater function is you pick any number between -3 and 0, and you substitute in these two equations. So for example, here I have y is my first function is equal to x u squared plus 2x. It's from here. This is my first function. And my second function is right here, y equal to -x. Now what I want to know is which one is the greater function. As I told you, when you guys want to apply this formula, it's going to be integral from a to b of the greater function minus the smallest one. So I'm going to find here which one is the greater function, and to do so, I'm going to pick any number between -3 and 0. What I got between a and b, you pick whatever you want. You can pick -2, -1, -1.5, is up to you. At the end of the day, the sign is going to be the same. Okay, and to simplify, I'm going to pick x equal to -1. You guys can pick -2, doesn't matter. I'm going to pick x -1. Oops, -1. So in this case, the first function gonna give me, if you substitute here x by -1, you guys will get here 1 minus 2 is gonna be -1. And here y gonna be 1. When you substitute x by -1, you will get -1, it becomes 1. And you notice now the greater value is 1, and the greater value is obtained from this function. So it means this function gonna be my f. So the integral becomes now minus x. I repeat again why I took minus x instead of this parabola, because I picked a number between -3 and 0, and I substitute in the two equations. And as I told you, the greater function gonna returns you the greater value. And doing so by replacing x by -1, because -1 is between -3 and 0. The first function returns us, -1, and the second one give us 1. So the second value here is greater than the first one. That's why we will take this value, because the second value here, 1, is obtained from this equation. And minus now g. In this case, g gonna be x u squared plus 2x. Just keep in mind, anytime you guys notice, the graph is not given and you want to know which one is the greater function, you pick any number from the interval of integration. So here in my case, the integral of integration is -30. And you pick whatever you want from there. I just pick, -2, 1, but someone else can take -2. But at the end of the day, you will get the same greater function. Any question before we calculate, this integral? Just keep in mind, if the graph was given, the greater function going to be on the top. and the smallest one going to be at the bottom. Any question before we calculate the area? So it makes sense for you guys how to find the given function? All right. Now let's see the calculation. All right. So we're done with the 0 minus 3 as I told you. We integrate now from -3 to 0 as I told you. Minus x minus this function. Now we drop the inner brackets. So we'll get minus x squared minus 2x. And if you add the first term and the last one, the third one, so you will get minus 3x minus x squared. And now we're ready to apply the power rule. Okay. Now, when you apply the power rule, the first term becomes -3 by 2x squared, and the second term, the antiderivative, going to be x cubed over 3. And what the FTC says, you calculate it at 0 first, the top. But at 0, when it's up to x by 0, you will get 0 here. Minus the bracket at -3. You replace here x by -3 is going to be -3 squared, going to be 9 times the 3, going to be -27. And here going to be -27. So when you calculate this bracket is going to be negative, but don't forget you have a negative sign, you know, at the front of the bracket here. So that will get a positive number, which is the area. So the 0 here, I repeat again, is obtained when you calculate the value taken by the antiderivative at 0. When you substitute x by 0, so this bracket gonna be 0, and that's exactly what the FTC says. Any question?
No question, sir.
Yeah. Any question?
Can you do more?
Pardon?
I want to see the whole solution.
Whole solution like
Yeah,
that?
yeah. Thank you.
You're welcome. I'm just gonna try to make the zoom a little bit. Is it okay like that?
Yeah, thank you.
All right. You're welcome. All right, I'd like to write down the solution. You guys can let me know if you have any question. Okay, let me know whenever you're done. So we'll see the next example. Pardon? Okay. Is it okay? All right, so let's move on. All right, so next example. We have three functions in this case. We have y equal to root of x, y equal to x minus 2, and y equal to negative x. Again, you guys can see here, the interval of integration is not given. We don't know the values of a and b for the integral, so we have to find them. Again, the three functions are in terms of x. So it means we need to find the x coordinates of the intersection point. But if you guys want to get the intersection point, you have to take two functions at a time. And you check all combinations. So all combinations in this case are first function and the second one, first function and the third one, and second function and the third. So we have three combinations. Okay, three possible combinations. So I'm gonna split here into three parts and we will solve each of these. Again, I just want to get the x coordinates of the intersection point. Yeah, 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 yeah. So you can draw the graph and you will find, for example, we can get one like that and get another one like that, and this, for example. Okay, so we'll get this area, for example. Is it okay? Now we have to find these three intersection point, right? So that's why I said, you have to take two functions at a time. So in fact, what I need is just the x coordinates of these three intersection point. Is it okay, guys? All right. To solve it, I'm gonna take the first function, for example, equal to the second one. Any solution here gonna be an x coordinate of the intersection point between the two functions, the first function and the second one. And next, I'm gonna solve intersection point between the first function and the third one, minus x. And the last case, I'm gonna solve x minus 2 equal to minus x. It's gonna be intersection point between the first curve, between the second curve and the third one. Is okay? I'm gonna repeat again. Here I'm trying to find these three intersection points between the three curves. And we have to take two curves at a time. In the first part here, I'm gonna take the first and the second equation, the first and the third equation, and last combination here gonna be second and third equations. Now to solve this one, we have to square both sides. So we'll get x equal to x minus 2, you square it. Right? And so we'll get x equal to, we expand the right hand side, is going to be, oops, I have x here. And we'll get here x squared minus 2x, minus 4x, sorry, and expand it, plus 4. Now I'm going to move, the x here from left to right. So I'll get x, you square it, minus 5x plus 4 equal to 0. Is it okay up to here? Right? All right, thank you. So we'll get here x. We can factorize, gonna be x minus 1 times x minus 4 equal to 0. And so this means x equal to 1 or x equal to 4. Oops, I'm gonna erase it. And x equal to 4. So since the my initial equation involves the square root, I have to double check if my solutions satisfies the initial equation. So here is my initial equation, and you notice here when you replace x by 1, you will get here root of 1 equal to 1 minus, which is equal to minus 1. So it means x equal to 1 does not satisfy the equation, so we have to discard it. We cannot keep it. Okay, so we'll keep 4 here because 4 satisfies, we can keep 4. So this one, we cannot take it. We remove it. I repeat again, the reason is you guys can see when you substitute here x by 1, so the equation is not satisfied because the left hand side becomes 1 and the right hand side is minus 1. And as you know, 1 is not equal to minus 1. But 4 satisfies the equation because when you substitute here, it's going to be root of 4 equal to 2. But you substitute here from the right, it's going to be 4 minus 2 also equal to 2. That's why we're going to keep only this solution. Is it okay? All right. So next we're going to solve the second. So it means we only have one intersection point between the first curve and the second one. And that intersection point is obtained at this point 4. We don't need the y value, the y-intercept. I don't need it in my calculations. That's why I will not calculate it. But if you want to calculate, if the question asks you to calculate it, so quite easy. You substitute, in one of these two equations. In the first or second equation, you substitute x by 4, you will get the y value. All right, from here, again, I'm going to scale both sides. I'll get here x equal to minus x u squared. So it means x equal to x u squared. And means x squared minus x equal to 0. Don't simplify here because if you do it, you will miss one solution. Don't simplify from this step, the third line. Don't simplify. So we'll get here. So we factor out x, gonna be x times x minus 1 equal to 0. And again, here we have two solutions. The first one is x equal to 0, and the second one is x equal to 1. Again, since my initial my initial equation involved in a square root, I have to double check. When I substitute x by 0, You guys can see I'll get 0, root of 0 equal to 0, equal to minus 0. This is, valid. So it means I can keep 0. And for 1, when it's sub x by 1, you get a contradiction because you're going to be root of 1 equal to minus 1. So it means we cannot take this one. It's not valid because it does not satisfy this equation. I'm going to take the first solution. Again here, I only have one intersection point between the first curve and the third one. And the intersection point is at 0. X equal to 0. Okay. Now, last case is intersection point between the second curve and the third one. I'm going to move my minus x from left to right. I'll get here. I'll get 2x minus 2 equal to 0. 2x equal to 2. So means x equal to 1. One solution. So here, we don't have square root. We don't need to verify anything. If you do it, also it's going to work. You can verify if you want, and you guys can see the solution is valid. And we have 3 solutions, as I mentioned here. One solution here between the first curve and the second one. Another solution between the first curve and the third one. And one intersection point between the second curve and the third. Okay? So since we have 3 solutions, we cannot write as one integral, because if you guys have one integral, you're supposed to get 2 bounds, A and B. So here we have 3 bounds. So it means we need 3 integrals. We need 2 integrals. Okay? And the integral going to be, in this case, I'm going to write it here. So the area in this case is going to be integral, as I told you, you start from the smallest value. So you have 3 values in green color here. 3 values. You guys have 4, 0, and 1. You start with the smallest one, and the smallest one, as you can see, is 0. And the second smallest one is 1. It means you have to integrate from 0 to 1. Plus now, second integral, because here we split our area in 2 areas. That's why we'll get 2 integrals. And now we integrate from 1 to 4. And you guys can see the 3 values, 0, 1, and 4. As I told you, first step, you have to find the interval of integration, A, B. You find the values of A and B. After that, you have to find the greater function. And you apply the formula. Is it okay up to here? Now, next step, I'm going to remove this. So if the graph was given, it's going to be easier to see exactly this point, and also, which function is the greater function. So since we don't know the graph, I'll show it later. But I'm going to use the first method that we've seen. You pick any number inside the interval of integration, and you substitute in the 3 functions in this case. And the greater function going to return you the greater value, as I told you before. Okay? All right. Again, I'm going to repeat here the 3 functions. we have y equal to square root of x as our first function. The second one is y equal to x minus 2. And the third one is y equal to negative x. Okay. Now, I'm going to pick a number. You guys can see at the bottom of this page, you guys can see we have two integrals. Now, for the first integral, I'm going to pick a number between 0 and 1 and substitute in these three equations in order to find the greater function and the second greater function. Okay, that's all I need. I'm going to pick a number between 0 and 1. I'm going to pick just 1 by 2. And as I told you, guys can pick any number from 0 to 1 in this case. Okay. If I pick 1 by 2, I'll get here square root of 1 over root 2. Just from the first equation. From the second equation, if you substitute this x by 1 by 2, I'll get 1 by 2 minus 2 going to be negative 3 by 2. Right? And from the last one, if you substitute, it's going to be 1 by 2. Negative 1 by 2. And now you guys have to pick which one is the greater value. You have one positive value, the first value, and the two other values are negative. So it means the greater value going to be 1 over root 2. And it's obtained from the first equation. It means the first equation is on the top. Going to be the greater function. That's why we use here root of x is my f. Minus the second greater function. Again, you guys have here minus 3 over 2 and minus half. Which one is a greater value?
Minus half.
So minus half is a greater value. Thank you. And it's obtained from the third equation. It means I have to use here the third equation. And dx. Is it okay for the first part?
Yes, sir. It's okay.
All right. For this, yeah. You have to take the greatest and the second greatest value function. Yeah. The greatest function gonna be root of x, and the second greater gonna be the third equation. Yeah. So for the second integral, I'm gonna pick a number between 1 and 4. Okay, I can take x equal to 2, for example. You guys can take it 3 if you want. At the end of the day, we'll get the same solution. Okay. Now, when you substitute in the first equation, so you guys will get here y equal to root 2.
Yeah.
And you substitute in the second equation, you get
0.
0. Exactly.
And minus 6.
And in the third equation, you guys will get y equal to
Minus 2.
all right, negative 2. Again, here, which one is the greater function?
Root over 2.
Okay, so greater value is root 2, and it's obtained from root of x. So it means we have root of x here. Minus
X minus 2.
So the second greater is 0.
0, yeah.
Is obtained from the second equation, x minus 2, as you said, gonna be, don't forget the brackets here. and dx. And done. So the question was, as you can see, to set up the integral, and we don't have to calculate it. Any question?
So we just minus the greatest y to the second greatest.
Yeah. If you remember the area,
In both two function.
pardon?
In both of them.
What did he say?
We minus the first and the second greatest in both two of them. How about the third?
The third is here. The third function is here. You see it here in the first integral.
I mean the greatest, the first and just the first.
Instead, you look at your formula. Your formula, you cannot get three functions inside. It's an integral from a to b, and you have f of x minus g of x. That's it. Okay? You cannot get three functions in your integral inside. That's why we need to find which one is the greater function and which one is the second greater function. When you get them, that's it, you subtract. That's what we did here for the first integral. And you can see here, we use the three functions. In the first integral, I use the first and the third. And in the second one, I use the first and in the second function. So it means I use the three functions, but you cannot get f minus g minus h. Three functions doesn't make sense, because as I told you at the beginning, your graph would look like this, for example. Okay, you have one intersection point here and another intersection point here, the second one, and the third one is right here. And for all of them, you can see this is my first function, this is my second, and this is my third. You see here, if you go from the first endpoint to the second one, the first function is on the top and the second function is the bottom. But when you go from the second intersection point to the third one, the first function is on the top and the third function is the bottom. You cannot get two bottoms, doesn't make sense.
Yeah, okay, sir.
Is it okay?
Okay, thank you, sir.
Welcome. Can I erase this? And if you look at the graph, it look like this. The area that we want to calculate is this one. I'm just gonna make a zoom if you guys wanna zoom in. Okay. And this is the area. I'm just gonna change the color. The area that's we're calculating is this area, bounded by the three curves. Is it okay? So you guys can see, is this the area just wanna get? This area. The green curve here is root of x, and the orange one is x minus 2, and the purple one is negative x. And we want to calculate the area bounded by the two the tree curve. You can see here, you cannot get two bottoms, doesn't make sense. The top is unique, the bottom is unique. You know, they may change when we change the interval, but if you stay in the same interval, the bottom and the top gonna be unique, because you just wanna get the area of the region bounded by the tree curves. Okay? I'm just gonna remove this and back to. So you guys can see this point here is 1. In fact, we split this area into areas. Okay? So this red area is the first integral. If you look at your integral, and you guys can see this point is 1. I'm just gonna change the color, take a black color here too. So visualize, you know, the point. Oops. So this point is 1 here. So here is 0. And as you can see, this is 1. Because h squared is just 1. And this point is 4. So here is 1. Right? So you guys can see we split it into areas. If you calculate the red area, the red region, so the area gonna be integral from 0 to 1. And you guys can see from the picture, if you integrate from 0 to 1, the curve on the top is a green curve, but the green curve is root of x. So this is root of x. This green curve is the curve of square root of x. So the orange line, I'm just going to change again. So this is y equal to x minus 2. And the purple one, so the purple one here, this line is y equal to minus x. So you guys can see from here, when you calculate the area only between the between 0 and 1, as you can see here, when x is between 0 and 1, so when x is between 0 and 1, you guys can see the curve on the top is a green curve. That's why we got root x minus the curve at the bottom is a purple line, and it's a minus x. This is your first integral. Plus now the second integral. So you integrate from 1 to 4. And you guys can see when x is between 1 and 4, the top is still equal to the green curve, and the green curve is root of x. But between 1 and 4, the bottom is now the orange line. So the equation of the orange line is x minus 2. And this coincides exactly to what we did before. So I just, want to show you here. You guys can get the integral by using the two ways. The first way is just, if you don't know the graph and you want to know exactly which one is the greatest function and which is the smallest function, you use exactly what we did before. But if the graph is given, don't do it. You're going to waste your time, because from the graph, you guys can see which function is the greatest function. As I told you, it's going to be just the function on the top. You can see the top is always the green function. Between 0 and 4, always the green function. But the bottom changes between 0 and 4, the bottom changes at 1, because between 0 and 1, the bottom is the purple line, and between 1 and 4, the bottom is the orange line. Is it okay? Any question?
So it's the square root x minus negative x, right?
Pardon?
It's the square root x minus negative x in the first function, I think.
No, it's a minus here. Sorry. It's a minus here. Okay?
Yes.
Yeah. Thank you.
Sir,
Yeah.
so what should we write down if we meet a question like this?
What do you mean? What should you write down?
Like the processes.
The
We just
question
need
is,
to.
okay, so
Okay, you go.
okay, so the question is to set up the integral. Okay.
Yeah.
You don't have to calculate it. And to set up the integral, you apply what the formula says. The formula says integral from A to B, and the greater function minus the small function, the smaller one. Okay. And in this case, you don't have to show me how did you do to find the greater function. Okay. I gave you two methods to find the greater function. You can find the greater function by using what I did previously. You pick a number in the right interval and you substitute in the equation. You take the greater function and the second greater function and you subtract. Otherwise, if the question provides, the graph, you don't have to do it. From the graph, you just check, okay, my function are in terms of x, the greater function gonna be the curve on the top. And then you don't have to explain it. I just did it in order to show you how to proceed in order to find the greater function. Okay, what I want to see in this kind of question is exactly the solution here, in A equal to integral and this second integral. That's it.
Okay.
Is it okay?
Yeah, thank you.
And don't forget now the first step, what I did, how did I do in order to find 0, 1, and 4? Because these values are not provided by the question. So you have to show me that part.
Oh, okay.
Okay, how to find 0, 1, and 4. You have to prove it by calculating the intersection point, the x coordinates. You have always to do it if the question does not provide the interval. If the question provides the interval, so you're lucky, you just apply the formula. You already know A and B. If A and B are not given, you have to find them. And when you find them, you have to show me exactly how did you do to find them.
Okay.
But now how to find the greater function or the smallest one, you don't have to show me. Any question? All right, so one more example. I'm gonna remove this. So in this case, you have two functions. This is my first one, my first function. And here is the equation of the second function. But in this case, the two functions are in terms of y. It's different to the previous example. Okay, So that's why you guys have this kind of parabola lying down on the y-axis, x-axis, sorry. Because the function, this is your parabola, but your parabola is in terms of y. So in this case, you guys can see this is the area that you want to calculate, this area between the green, the blue parabola and the red line. Okay. So to find it, so we have to find the intersection point here and this intersection point. But since my functions are in terms of y, I only need the y coordinates of the intersection point. I don't need the x coordinates because my functions are in terms of y. It means my integral gonna be in terms of y. In this case, my integral the area gonna be integral from a to b f of y, because the functions are in terms of y, minus g of y dy, not dx. Because the function are in terms of y, that's why my integral should be in terms of y. And since my integral should be in terms of y, that's why I need the y coordinates only, the y coordinates of these 2 points. So here from the graph, I can find them, but I'm going to show you how to find them by calculation because sometimes the graph is not given. So from the graph, you guys can see here, the value here. What is this value? So the first one is quite easy, is 0, but the second one is
7.
7, exactly. So it means A is 0 and B is 7. But if the graph is not given, so by calculation, we have to do it like that. So this is our first case. So we're done with this. So now we want to get, as I told you, we need the y coordinates. This is different to what we did before. In the previous examples, we found the x coordinates because the functions was in terms of x. Now my functions here are in terms of y. That's why I need the y coordinates only, except if the question asks me to find all coordinates. But in my calculations, I only need the y coordinates. So I'm going to equate the two equations. This is the equation of the line, x equal to negative y. And this is the equation of the parabola, x equal to 6y minus y squared. I equate the two equations and solve for y. And if I solve for y, I'll get, y equal to 0 and y equal to 7, as your friend said, just from the graph. But if the graph is not given, so you have to do it like that by calculations. Any question?
No, sir.
All right. So since you guys now know the value of y and the value of b, so the value of a is 0, the value of b is 7. So it means you integrate from 0 to 7. As I told you, you have always to integrate from the smallest value to the largest one. You integrate from 0 to 7. Next step, you have to find which of these two functions is the greater function. Which one? And as I told you, pick any number between 0 and 7. I'm going to pick 1. So you guys have here the first equation, x is equal to minus y. And the second one, x equal to 6y minus y squared. What do you guys think? Which one is a greater function?
6y minus y square.
Exactly. You pick any number between 0 and 7 and you substitute in the two equations. I'm going to take, for example, y equal to 1. Any number between 0 and 7. 0 and 7 are the values of y. Don't take x equal to 1. So we take y equal to 1 between 0 and 7. And in this case, the two equation becomes here x equal to, when you substitute here, you will get -1. When you substitute in the second equation, you will get here 6 minus 1, which is equal to 5. So you guys can see here 5 is greater than -1 and 5 is obtained from this equation. So it means this equation is a greater function, the parabola as your friend said. But if the graph was given, you don't need to do the calculation here as I told you. In this case, don't say top minus bottom because the functions are in terms of y. You use top minus bottom if the functions are in terms of x, but in terms of y is going to be right minus left because the greatest value is going to be on the right. In terms of x, the greatest value is going to be on the top. But in terms of y, the greatest value is going to be, on the left. So that's why it's going to be left, and left is the blue curve minus right, the line. Okay? And that's exactly what I did here. Now we integrate from 0 to 7. That's what we got. And as I mentioned now, it's going to be right minus left, or you use what I did, just substitute a y by 1 in the two equations. And you notice, this is a greater function minus the smallest one. And you drop the inner brackets, you guys will get minus y squared plus 7y, because here you have 6y minus, it becomes a plus y. That's why you got here 7y. And when you use the power rule, you guys will get the antiderivative. You calculate it at 7 is going to be 343. And at 0, you get 0 here. And after calculation, you will get 343 by 6 unit square. Any question? All right, so if there is no question, I'm gonna take the attendance before letting you go. You have 6 more minutes before 10. So you guys are good? Can I stop sharing my screen?
Yes, sir.
Yes, sir, sure.
Yes, sir.
Okay, thank you. Your mic, please.